Okay, so I just worked out this problem, number 32, out of the Larson book in section 4.4 of the chain rule. And we did the quotient rule within a chain rule. And then I wanted to work it out a different way, see if this is any easier. Let's write that as a product rule instead. So we're going to take the bottom, which is to the third power, and we're going to move it to the top. And when we move it to the top, of course, the exponent becomes negative. So now let's apply the product rule. So the derivative of the first is a 3, bring the 3 down in front, and then we lower the power to its 2. So it's 3 something squared. And then we have to remember to take the derivative of the inside, which is the 2 comes down, multiplies by the 3, and we get 6x to the first power minus 0, which I don't need to write. So this whole thing is the derivative of the first. Now we have to do that times the second. Okay, now we just got to do this again. Plus, now we got to do the derivative of the second, which is going to be negative 3, 2x plus 3 to the negative fourth, dropping the power by 1, the negative 3 going in front. And then times the derivative of the inside, 2 plus 3, or 2 plus 0, and so we just write 2. Slope of this function is 2, always. So that's the derivative of the second function times the first function. Okay, so now we would somehow have to take this and make it look like that. So why don't we start by moving negative exponents down and combining, like multiplying out the constants. So let's take the 6x and the 3 and multiply those to get 18x. And then we'll have our 3x squared minus 2 squared. It's looking pretty good right there. And then we'll move this thing to the bottom and get 2x plus 3 to the third power. And then over here we get plus, let's do our, actually let's just do a minus. Minus, because we've got 2 times 3, so that'll be 6. This will stay in the top, 3x squared minus 2 cubed, and the 2x plus 3 will go to the fourth power, will move to the bottom. So now we're pretty close to like terms. To get like terms, I just need an additional 2x plus 3 over here, like that. So now we'll have a common 2x plus 3 to the fourth. Okay? And just to clean things up, we can worry about simplifying in a little bit. Let's just kind of write what we got here. So we got 18x times 3x squared minus 2 squared times 2x plus 3. And then over here we've got minus 6 times 3x squared minus 2 cubed. So what I would do is I'd look at this as two different terms. And we got some common stuff. So what's common here? We've got a common 6. And we've got a common 3x squared minus 2 to the second power. So we could actually pull that out. So 6 times 3x squared minus 2 to the second power. Looking familiar? Okay. If we pull out a 6, we'll have a leftover 3 and a leftover x. These are both gone, but then we'll also have a leftover 2x plus 3. Okay, so maybe I should have gone with brackets here. And then the minus sign, if we pull that out, the 6 is gone. 2 of the 3x squareds minus 2's are gone. So we're going to have 1 3x squared minus 2 left. And pretty much when we combine this, I'm thinking we're going to get this. Let's find out. So this part's all good. Copy it back down. Here, distributing, we're going to have 6x squared plus 9x, and then minus 3x squared plus 2. Okay, so then last thing to do here, I think, combine like terms in here. I'm going to go back to parentheses. 6x squared minus 3x squared is 3x squared. 9x plus 2 are copied, and the 2x plus 3 in the bottom are copied. Boom! Totally the same. Right? Read it and weep. Well, maybe read it and cheer, I don't know.